Hello everyone, welcome once again to another session of learning. Today in our mathematics class we'll be looking at binary addition and subtraction. Binary addition and subtraction. Remember, in our last lesson in mathematics we looked at the binary number system, and in that lesson we looked at how we can convert binary numbers to decimal numbers and decimal numbers to binary numbers. And by decimal numbers we mean our regular numbers like 1 for 14, 25, 139. So these numbers are in the decimal number system. Okay, I remember we mentioned, I think in our first lesson, that all the numbers in existence in this decimal number system are formed by a combination of the digits from 0 to 9. All the numbers you have in existence in this Arabic numeral, which we also call the decimal system, are formed by the digits from 0 to 9. And by that we mean the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are all the numbers that combine to form the different numbers we have. So this is the decimal system. And we mentioned that any extra addition to 9, for instance, if you say 9 plus 1, it can be housed again under units. Remember, all these are single digit numbers. So by the time you add 1 to 9, there is no more symbol to represent that number. We don't have any more symbol to represent the number that is bigger than 9, because 9 is the largest digit. Okay, so what happens is a combination of the different digits begins to occur to form larger values of numbers. Okay, so like 9 plus 1, which is 10, you will now come back to using the digits 1 and 0 to form the number 10. And what happens? This is a 2-digit number, unlike all these ones here that are single-digit numbers and that come under units. So once it becomes 2, you have to use the tens column. The number can be housed in the unit column alone, so there has to be a spillover to the tens column. Now I'm just trying to go over this because we're going to find out as we continue to explore the binary number system that the principles that play out here are exactly the same in the binary system. Although in the decimal system you have 10 digits, okay? You have 10 different digits that combine to form all the numbers, whereas in the binary system you have only 2 digits, the digits 0 and 1. And that's why they call it binary system. Bi means 2, okay? So there are just 2 digits in this number system, and those 2 digits are the digits 0 and 1. So here 0 is the least number and 1 is the biggest number. These are the only 2 digits. That means that any extra addition to 1 which in the decimal system should give you 2, here, because 2 does not exist in the binary number system, it now looks exactly the way 9 plus 1 will look. 1 plus 1, please pay attention, in this binary system, the result is going to be exactly the way 9 plus 1 will occur. Remember, there is no more symbol to represent a digit bigger and a value or a number that is bigger than 9, so we start combining. The same way, because 1 is the largest digit or number in the binary system, if you add 1 to 1, you can write 2. So what happens? It's going to become 0, and that 2 will be a spillover to the other position, which is like that. Just like when you add 9 plus 1, you have 10, you have 0 now under the unit, and then the 1 spills to the other position of tens. It's exactly that same way. So when you do 1 plus 1 in binary system, there is no 2 in the binary system, so that becomes 0, and that 2 is converted to 1, and it comes to the position, the next position. So I'm just trying to go over the decimal system and the way it operates so that you'll be able to understand how the binary system also functions. So today in our lessons we'll be looking at binary addition and subtraction, how we add binary numbers and how we subtract binary numbers. That is our focus for today. Okay, so we have an example right here on the board. We're going to work this out together. So right here we have the numbers. I know I mentioned it in the last lesson that this is the language of the computer. Okay, so don't think that learning about binary numbers is a waste of time. Having an understanding of the binary number system and how it functions will give you an understanding or will help you to have a glimpse into the world of the computer. Okay, so it's really important. This is the language of the computer, and we know that we are in computer age right now, so this is something that is valuable. Okay, so let's take a look at what we have on the board. We have the numbers 1010 plus 1011. Okay, this number you can't call it 1010 or 1011 because it's a different number altogether, because it's a different number system. It's a different number system. So let's do the addition. Like I mentioned, it operates just like the decimal number system, but you have to note that once you get to the highest number, you definitely have to cause a spillover to the other side, just like we have in the decimal. Okay, when you exceed a single digit number. So let's start with this. We always start our adding from the right end and we work towards the left, remember? So 0 plus 1 is 1, right? Because 1 is a number in the binary system. 1 exists. Okay, so we have 1. 1 plus 1. That is supposed to be 2. But we know that in the binary system, there is no number like 2. So what happens? Exactly what happens when you have 9 plus 1, 10. Under unit, you no longer have anything there. So your 1 plus 1 will be 0 because that 2 gets transferred as 1 to this next position. Okay? So that 1 now, you add it. 1 plus 0 is 1 plus 0 is 1. Okay? Now we get to the last stage. 1 plus 1 again, we find is 2, but we don't have 2. We can't write 2. So we write down 0, and the spillover comes here as 1. So when we add the number 1010 and the number 1011, the answer we get is this. I hope this is clear. Let me quickly go over it again for the sake of those who probably didn't understand. Now, these are the numbers we are adding, okay? They are binary numbers. And in the binary number system, we have just 2 digits, and those are the digits 0 and 1. So these are numbers we are adding. We arrange them the normal way we arrange our numbers in the decimal system when we want to add. And when you want to start your addition, just like we also do in a decimal system of numbers, we start from the extreme right and we work towards the left. Okay, and remember I mentioned that you do not have any other digit in existence, so anything more than 1 you cannot write it down. What you do is you carry over, just like you do in the decimal number system. That's why I wrote like 9 plus 1, for instance. Remember, 9 is a unit number, it's under unit. Okay, 2 is under unit, 3 is under unit, and stuff like that. But once you get to 9 plus 1 is 10. Now we know we cannot put 2 digits number under unit. So what do? We have exceeded the largest number. 9 is the largest number in the decimal system. So what happens? Unit becomes 0, and then the 10, the 1 gets transferred to the 10th position. It's exactly what happens in the binary system as well. Because 2 doesn't exist, once we get addition and then it gives us 2, we are going to take that 2 as a 1 and transfer it to the next position. So let's start addition. 0 plus 1 is 1. 1 can stay because 1 is a part of the binary numbers. Then 1 plus 1 is 2. But we know we can't write 2 here in the binary number. So that 2, we write down 0 and take it over here as 1. The 2 becomes, you write down the 0 and you move it as 1 to the next position. So 1 plus 0 is 1 plus 0 is 1. We have 1. Again, we have 1 plus 1. We know that it's supposed to be 2, but we do not have 2 in the binary number system. So what do? We write down 0 and we carry that 2 as 1 to the next position. So 1 plus nothing, that gives us 1. That's the one we have here. It's a very interesting concept, really. I hope we understand this. We're going to take another example and see how this works before we move on to subtraction. So let's look at the second example. So right here we have the numbers 1111 plus 1100. So let's try to add these numbers and see what we come up with. Okay. So 1 plus 0 is 1. You write down 1 because there's 1 in the binary system. 1 plus 0, 1. 1 plus 1. So here again we find out that we cannot write 2. So what do? We put down 0 and we bring that as 1 to the other side. Okay, like carry it over to the other side. Now you have 1 plus 1, which is 2. Plus 1, which is 3. Now remember, the binary system cannot accommodate 2. 2 turns to 0 and there is a 1 that spills that you take to the other side. Because how do you get 0 actually in binary numbers? It's simply like you are doing 2 divide 2 and you write the remainder. Okay, so when 2 divides 2, the answer is 1, remainder 0. So that 0 we normally put down is actually like a remainder from when you divide 2 by 2. So you write the 1 you move it over to the other side, but you write the remainder, which is the 0. Now look at the case of 3. Remember, we are adding 1 plus 1 plus 1, which is 3. So you're going to do 3 divided by 2. If you do 3 divided by 2, if you divide 3 by 2, you are going to get 1, because 2 can only go into 3 once, and then there is a remainder of 1. So you see, 2 divide 3, 1, remainder, there is a remainder of 1. So this remainder of 1, you are going to write it. Remember, you write the remainder. And the 1 that is spilling over from here, it moves to the next position as 1. So 1 plus nothing will still give you 1. I hope it is clear. Let me go over it again for the sake of those who are confused. 1 plus 0 is 1. 1 plus 0 is 1. I know that's not confusing. Then the next one is 1 plus 1. That's supposed to be 2. But remember, in the binary number system, you do not have 2. So what do? You divide 2 by 2. Okay? I know I explained it to you that you just simply write down 0 and carry the other as 1. But what actually happens is the 2 you get divided by 2. And when you divide 2 by 2, it is 1 remainder 0. So what you do is to put down that remainder, which is the 0, and you carry over the 1 to the other side. Remember, you have 1 remainder 0. You wrote down the remainder. Then the 1, you move it to the other side. Now in this second position here, what happens? You add the 1 you brought over. 1 plus 1 here is 2, plus the third one. That gives us 3. So we know we cannot write 3 down. What do? You do your 3, take away 3 from 2. Or how many times can 2 go into 3? It's only 1. So you write down 1. And what is the remainder? There's a remainder of 1. Remember, again, you put down the remainder, which is 1 in this case. And then the 1 that is the main answer, you move it to the next position. That's the one you are seeing here. And so you now do 1 plus nothing, because there's nothing on this lane. 1 plus nothing is 1. So this will be your answer. I think we need to take one more example of this type so that people will understand everybody will understand what we are trying to explain, okay? Especially when we get up to 3. All right, so we have a third example here. Let's look at this once again. So here we have 1 plus 1. 1 plus 1 is 2 ordinarily, but since there is no 2 in the binary number system, you simply divide this 2 by 2. What will it give you? 2 divided 2 is 1. Is there any remainder? No, the remainder is 0. So what do? Put the 0 down. You put the 0 down, and the answer you got, which is 1, you transfer it to the other position. Okay? Now, when you add this, you have 1 plus 1 plus 1. It gives us what? 1 plus 1 is 2, plus 1 is 3. Again, we know we do not have 3 in the binary number system. There is nothing like 3. So what do? Divide that 3 by 2. If you divide 3 by 2, how many times will 2 go into 3? Is 1. Can only go once. And then you have a remainder of 1. Again, the remainder is what you will write down. So you write the remainder down. Okay? I want to make sure you're seeing this. You see that? So again, you put the remainder down, and the real answer, which is the one you got, you move it to this point. Move it to this point. Okay? So 1 plus 0 plus 0, that is 1. I hope you're getting this. Then the next one, 0 plus 1 is 1. And lastly, you have 1 plus 1. So 1 plus 1 is 2. So like you have again, divide that 2 by 2, you have 1 minus 1 remainder 0. So you put down 0 here because there is no 2 in binary number. Put down 0 and you bring the 1 here. Okay, so 1 plus nothing is 1. So when you add this number, this is what you get. I hope this is not confusing. Let me go over it again. 1 plus 1 is 2, but you don't have 2 in binary number. So you write down 0 and carry it as 1 to this second position. So that one you carried plus 1 is 2, plus 1 is 3. We don't have 3 in the binary system. So what do? Divide that 3 by 2, okay? Because this is a binary number system. When you divide it by 2, you are going to have 1 remainder 1. Because 2 can only divide 3 once, and then there will be a remainder of 1. So that remainder is what we write down. And the real answer, which is the 1, we move it to the next position. Okay? You only write down the position, the remainder, you move the answer to the next position. Write down the remainder, move the answer to the next position. So the 1 here, we move it to this position where you have 2 zeros. So 1 plus 0 is 1, plus another 0 is 1. 0 plus 1 is 1. 1 plus 1, here again we meet an answer that we can write down, 2. So what do? 2 divided by 2, it is 1 remainder 0. So write down the 0 and carry the 1 to the next position. So that 1 plus nothing gives you 1. Okay? I believe by now you understand what we're trying to do. Okay? It's a simple thing. Like, once you pay attention to the way it works, if you have an understanding of how the decimal number system works, binary will not really be an issue. Okay? Just know that you can't exceed 1. You can't go beyond 1. So once you get to 1, what is going to happen will look exactly like what happens when you have reached 9 under unit and then you are crossing over to 10. You know you cannot write 10 under unit. So what do? Put down 0 and you carry 1. It's exactly what you do in the binary number system. So the next examples we're going to look at are subtraction. We're going to look at how subtraction occurs in the binary system. Alright, so let's take a look at this example of subtraction in binaries. We have the numbers 100 minus 10. Sorry, minus 10. Okay, 100 minus 10. So you arrange normally the way you would in a decimal number system. Okay, so let's go. So 0 minus 0 is 0. The next position, you have 0 minus 1. We know we cannot take away 1 from 0. It's going to give us a negative number. So what do? You borrow. Remember, this is what we do even in our decimal number system. Okay, when you have a larger number, there is need for you to subtract a larger number from a smaller number. You need to borrow. We always do that. Okay, so that's what we do here, because we can't take away 1 from 0. But remember, we are dealing with binary numbers here. This is a binary system. Whatever you borrow in the binary system it has the value of 2, because we are in the binary system. Okay, so whatever you borrow has 2. In the decimal system, that's why it is called decimal. Deci is 10. Okay, deci refers to 10. So in the decimal number system, whenever you borrow borrow from a certain place to take to somewhere else, that number you borrow is always 10. If you borrow 1 to add to something else, it is always 10, because it's a decimal system. Deci refers to 10. But here we are dealing in the binary system. By rather refers to 2. So whatever number you borrow here to help some other number is always 2. The value is always 2. So here we borrow from here to aid this 0, because we can't take away 1 from 0. 0 needs help. So we go to the closest neighbor to borrow. So whatever we borrow in the binary system must be 2, not 10, as we have in the decimal system. So you bring the 2 here. Now 2 minus 1 is what? Is 1. So this will be our answer. I hope this is clear. So we have 100 minus 10. So 0 minus 0 is easy, is 0. But here we have 0 minus 1. We know that we can't take away 1 from 0. It's going to give us a negative number. So what do? We come here to borrow. Now what we are trying to just explain here is, unlike a decimal number system where what you borrow is 10, okay, and you use it to help the number that is in distress, in the case of binary numbers, whatever you borrow has the value of 2. That's why it is called the binary system, because it's a system that has just 2 is what the value of whatever you borrow is. So you bring the 2 here. So this 2 now, remember the 2 is added to 0, is still 2. 2 take away 1 will give you 1. So this is what you get as your answer. Okay, so let's look at another example. Let's take a look at another example. Example 2. Let's do let's do 1110 minus 1001. Okay, let's try and do this subtraction. So you have 1 1 1. We still have space. Let's see. Let's take this up a bit. So example 2 is 1110 minus 1001. Okay, so let's do arrangements. We need to. Okay, so you have 1110 minus 1001. Okay, all right. So let's go. Here you have 0 at the end here. We cannot take away 1 from 0. It's going to give us a negative number. So what do? We come to the nearest neighbor to borrow from there. So when you borrow this 1 here and it moves over to this point, it becomes 2. Okay, so this 2 minus 1 will give us 1. Now remember, you borrowed from here, so there's nothing left here. You took this 1 that we have here. So when the 1 came here, because it's a binary system, it became 2. In the decimal system, if you borrow 1 like that and bring it to the other side, it will become 10 in our normal decimal system. But this is binary, so whatever you borrow is 2. So this 1 no longer exists because we have used it to help this 0. Now here you have 0, so 0 minus 0 is 0. Now 1 minus 0 is 1, and 1 minus 1 is 0. So this is our number when you do a subtraction. I hope this is easy. It's just exactly the way our decimal system is or operates. Okay, all you just need to know is that if you cannot subtract a certain number from another one because the one you're subtracting is bigger, just go to the one next to it or anyone that is available to offer help. You borrow from them, but have it in mind that whenever you borrow in a binary number system, what you borrow always has the value of 2. It always has the value of 2. Okay? So let's take a last example of a binary subtraction. So we have the number 100 minus 1. Okay, so as we can see here, we can't subtract 1 from 0. It will give us a negative number. So what do? We go to the next door neighbor. But unfortunately, next door neighbor has nothing too. It's also 0. What do? We take and walk again. Okay, now we find someone that can help here. So we borrow what this one has. Remember, even in a decimal number system, when you borrow like that, you don't jump from this one to the first 0 that needs help. No. So this one that is borrowed from here comes to this and becomes 2. Right? So it becomes 2. So this 2 plus 0 is 2. Now that means it's from this 2 that this number can now borrow what it needs. So we take 1 out of this 2 and we transfer it here. So this one also becomes 2. It's exactly the same way it works in our binary system. Okay? It's exactly the same way. Let's finish this. I'm going to show you why I say it's exactly the same way. Okay, so this 2 now minus 1, you have 1. Remember, we have 2 here, but then we borrowed 1 and brought it here. So here is remaining 1. Okay, so 1 minus nothing is 1. Remember, the first one is already gone, so that place is 0. You can write it if you want. So you have 0, 1, 1 as your answer. Okay, let me show you something like this in our normal numbers. Okay, let's say this is 100 minus 1 in our normal numbers, right? We can't subtract 1 from 0, so we come here, nothing to offer, so we borrow from here. Now remember, in our decimal system, if you borrow, this is 10, so this number becomes 10, isn't it? But we are not stopping there, so we borrow 1 again from there and come here. So what is remaining here? This place is now remaining 9, right? And this is 10. So 10 minus 1 is 9. Remember, it's 9 that is now remaining here. You write your 9. It's exactly what we did here. When you borrow, you first go to the next number, you drop it there, but that's not the final destination. You take away 1 out of what you dropped here and move it to the point where it is needed. But remember, in the binary system, whatever you are moving has the value of 2. So 2 take away 1 is 1. Now here was 2, but because you moved 1 out of it again, it is remaining just 1. So 1 minus 0 is 1. And that is our final answer. Okay, so for binary, this is where we're going to stop a binary lesson. I think in your next maybe the next level, you proceed to multiplication and probably division of binary numbers. But for this our lesson and for this our level, this is where we're going to stop in our exploration of the binary number system. Okay, so I hope to see you again in our next class. Please help us share this video, help us like this video, subscribe to our channel, and we'll see you again next week. Stay blessed and stay safe.